Hi, today we're going to be interpreting the output from a basic bivariate regression to sort of refresh your memory from what we went over at the end of 622. This will be a two-part video, the first part of which will just focus on substantive interpretation of the coefficient on an independent variable as well as its statistical significance. And in the second component, we'll get into R squared, F statistic, and sum of squares. But for now, we're just going to focus on the coefficient. For this, I am using the world's data from 622 in the Pollock textbook. So you should have that available from 622. If you don't, just get in touch with me. So what I'm going to do is just do a basic bivariate regression here. Let's say I'm interested in the effect of population size on economic development. In that case, I might regress a country's GDP, the dependent variable, on its population, an independent variable. Now remember that in Stata, the dependent variable always comes before the independent variables. Here's the output from a basic bivariate regression. Keep in mind, if I wanted multivariate regression, I would simply add more independent variables after population 08. But for now, we're just focusing on simple bivariate results. For now, let's focus on the coefficient. Ignore for now the upper part of the output. Here we see GDP 08, our dependent variable. It always goes there. And below that, we have our independent variable, population 08, as well as the constant term, or intercept. Let's focus on substantive interpretation for now. Remember that we always interpret the coefficient in OLS as the effect on the dependent variable of a 1 unit increase in the independent variable. And we express it in terms of the units of the dependent variable. The units of the dependent variable here are billions of dollars, and those of the independent variable are millions in terms of population. So this number here tells us that for every 1 million person increase in a country's population, on average, a country's GDP will increase by $6.16 billion. Now keep in mind that this is a probabilistic statement, so note that I said on average. That's an important part of interpreting it. Next, we go and get a sense of how confident, or the variation around this estimate of the effect of population on GDP. This can be thought of as the standard deviation of this effect. This tells us that the standard deviation is about $600 million. So in terms of the effect, that's a relatively small standard error. Now you'll remember from 622 that the standard error and the coefficient go into the calculation of first the t-statistic, and from that we can get a p-value, and we can also get an interval estimate of the coefficient. And those three things deal with statistical significance. Let's look at the t-statistic. We get 10.14. Now remember from 622 that we use a t-distribution to get a p-value from this t-statistic. So any t-statistic around 1.96 or 2 is going to get us very close to the cut point for conventional levels of statistical significance. Certainly we see we have a t-statistic of 10.14. So we're certainly sort of way blows it out of the ballpark, certainly statistically significant at conventional levels. And we go over to the p-value here and see that the p-value is certainly less than 0.05. In fact, it's less than 0.001. And this can be interpreted as the probability that we would observe this effect from our data if the null hypothesis is true. Now keep in mind that we are doing a two-sided test. So the null hypothesis here would be that there is no effect of population on GDP. The probability that we would observe this effect if there was no effect of population on GDP in the real world is actually less than 0.1%. Now, while we're dealing with very small probabilities here, note that the p-value is never perfectly zero. These are probabilistic on average statements. So we would not say that the p-value is 0. We would say that it is less than 0.001, which is what this tells us. The third way to interpret statistical significance is by looking at the 95% confidence interval, which is derived from the coefficient and the t-value for 95% confidence. This tells us that we're 95% confident that in the true population of states, the effect of a 1 million increase in population on GDP is between 4.96 and $7.36 billion. The fact that these numbers don't encompass 0, meaning the lower bound of the confidence interval is positive, not negative, tells us that we're confident that the effect is positive to a very high degree. The third issue you would get into is substantive significance. Is this effect meaningful? Now, that's a question for theory and your own knowledge of the background, something you have to justify in your own paper using your own intuition and logic. Now let's look at the constant term. The constant term is interpreted as the value for the dependent variable when the value for all independent variables in the model are held at 0. So this can be interpreted as a country's GDP when it has a population of 0. So a country on average with no people in it has a GDP of about $163 billion. Obviously, that doesn't make very much sense. It's not a requirement that the constant term be substantively meaningful. It serves a statistical purpose. Okay, that's it for now. In the next video, we'll go over the other components of the regression output. Thank you.